Okay, here's a small section of the textbook here, and it's giving us an idea of how this working out of a slice goes. So here is the X-ray tube, and it's going to go all the way around it. Now this is this over here, and it just does one layer at a time from the side to capture one slice. So that would be the slice through this person's torso. Here, that's probably what we're seeing, maybe a spine and kidneys here or something like that. And so first of all, it's going to go through in this direction, then it's going to go through in that direction, then it will go through in that direction, through in that direction, and then it knows enough, because there's no need for me to come from here because I've already got that from this side. There's no need for me to come from here because I've already got that from this side. I don't need this because I've already come down from this side, and I don't need this because I've already come through from this side. So just literally that way, that way, that way, that way, and that is enough for me to deduce all of the voxels in that slice. Now it may be, looking at this one again, perhaps we are looking at a head, and that there would be lots and lots and lots of slices all the way through that whole head, maybe to find a brain tumour or something like that. Now this isn't particularly good for a human being because lots of X-rays, as you know, is lots of absorption of ionising radiation. And so they don't like to give CAT scans if they don't have to. An MRI is much better in that sense, or at least with our current understanding of an MRI. Ultrasound is better, but ultrasound doesn't give the kind of images that we need. An MRI does, but it's a bit rarer. There is also another one called PET scanning, which is positron emission tomography. We don't need to know about that one in our syllabus, but if you're interested in it, if you're perhaps going to study medicine, then it would be a good idea to look that one up. So the principle is slowly, slice by slice by slice, moving over the body until it is done. So they don't like to give them to children at all, because children have to really need those X-rays to be having all that radiation, all that ionisation radiation. So the threat has to be enough for what they're scanning for them to do it. Not that if you have one, you're definitely in big trouble or anything like that, but if they can avoid it, they will, and I presume they're quite expensive too. NMRI are rarer, probably again, because the scanners themselves are more expensive. Okay, so I'm going to show you with a really simple image, and actually this is that. I'm just going to go through this whole thing here on the next page, and I'll ask you to perhaps do that yourselves afterwards as well, and I'm going to explain how it's figuring out the voxels. Okay, so let me do that with my own worksheet, and this is one that I've given to you so that you can have a go as well. Here we go. So what we have to, what we're actually doing is working through this backwards, because in the end what the scanner is trying to figure out is what these four voxels are. So we're going to do it back to front. We're going to give the four voxels and then show how the computer builds up the image all together, and then at the very end it will show us what we have to do when we get a final, I'm going to call it memory array, to find out what those four voxels must have been. Okay, so I'm going to randomly now make up four voxels here. So 7, 3, 4 and 1. Okay, so that is what the computer is actually trying to figure out. So I'm giving the answer in advance and we're working backwards through it. Okay, and so that will always be what's being scanned. So this is showing what happens when I scan in this direction, and then as we go down, look, this is what happens when I'm scanning through this direction, and so on and so forth until I've done the 4 scans I need to do. So I can in advance write down what those voxels are in these, because I already know the answer. So there we go, it's on that one, and over here on this one. I need to just move it over a bit so you can see. And then this one here. Make sure I do it the same, otherwise I would make a mistake of it. Right, so let's go back to the very first bit. So you start off with a memory array that is adding up the values of the absorption that goes through. So if it were in air, then all of all of the X-rays would go through to the other side, there would be zero absorption. Okay, so what we're now saying is that we're going to scan through from this direction to see how much is absorbed. And all I do is, let's say, it doesn't matter what this value is to start off with of the intensity of the X-ray. Let's say, though, for argument's sake, it's 20. So let's say it's 20. And what this will do then is take off and figure out how much was absorbed on the other side. As long as it is enough to get out of the other side, in terms of its value, it's enough for us to figure out what was absorbed. So for this direction, going through these two voxels, which could be made up of millions of them. Remember, this is a computer building it up, so it needs a lot of processing power. We're just going to work out these four. So 7 plus 3 is 10, and then 4 plus 1 is 5. And then to add to my memory array, I'm going to write 10, 10, so that's in that direction, and then 5 and 5, like that. And that is going to be added to my memory array, and that's what I will now have over here. So this is like a running total. Sorry, let's bring that up. This is like a running total now of what has been absorbed. So that's after the scan from the right-hand side, like this. So we're going to go on to the next scan now, which is going diagonally. So we're going, it seems, anti-clockwise around. So if I go from this direction, this, if the ray goes through here, only 7 will be absorbed. So I'm writing 7 in that one. If it goes through these two, it will also be 7, 3 plus 4. And this one, look, is 1, like that. Okay, so that is my memory array there. So now I'm going to write that in to here. So how does that look? Well, to start off with, in the top corner I've got 7, and then through these middle ones, which is this, I've got 7 and 7, and then this one is 1 here, like that. Okay, and I'm going to add those on to the memory array over here. So I've got 10 plus 7 is 17. I've also got 10 plus 7 is 17 there, and then 5 plus 7 is 12, and then 5 plus 1 is 6, and that's where we are at the moment. Okay, so this then continues on like this. So we're now going to do the downward direction. So if I come through the top here, 3 plus 1 is 4, 7 plus 4 is 11, like that, and that gets added onto my memory array up here. So this time I've got, let's make sure I get this right. So in the downward direction I've got 11, 11 and 4, 4, like that, and I'm going to add that on to the array from before. So if I can bring them to there, if I can see them all on the screen at once. So now I've got 17 plus 11 is 28, and I've got 17 plus 4 is 21. I've got 12 plus 11 is 23, move that up a bit, and then 6 plus 4 is 10, and that's where I am so far. So I can get rid of the other sheet now and just continue from there. So now we're going to do our scan through, and this is the last one, through this direction. So this is just going through 3, so that's 3, 7 plus 1 is 8, and that is 4, like that. And now to put it into my my thing here, I've got then 4 here, I've got 8, and then I've got 3, and I have to add that on to the memory array. So I will do that now. So we've got, let's see, I've got 28 plus 8 is 36. I've got 21 plus 3 is 24. I've got 23 plus 4 is 27. and then I've got 8 plus 10 is 18, like that. Okay, so so far so good. Okay, let's go back to the original, and we're going to notice some things now. Altogether, the thing has been scanned from 4 directions, but let's take a look at something here. If I go through the first direction, 10 plus 5 makes 15. The second direction, 7 plus 7 plus 1 equals 15. From above, 11 plus 4 is 15. And then lastly, 4 plus 8 plus 3 is 15. So the background that we have found, whatever is left over, always adds up to 15. So I can now get my final one, and I've got to take off 15 from each of them, okay, on this one. So that's my background. Now I'm going to take the background off of each of these voxels. So 36 minus 15 is 21, sorry. 24 minus 15 is 9. 27 minus 15 is 12. And then 18 minus 15 is 3. Now if I divide that through by 3, then I get my final answer, which is 7, 3, 4, 1. So in advance we already knew what the voxels were, but all that the computer really does is to do those 4 scans to get that running total value here. Then it works out what the background is, which is the total of the 3 or the 2 from each direction. It takes that background away, which is what we did here, and then divides by 3, and then it can deduce what they are. Now once it's deduced all those individual bits, it can then figure out what the whole slice looks like. So that, going back to our image here, then it can figure out that that slice must be like this. It figures out that shape. So we've just done it with 4 to show how it does it, but the computer can do it with obviously many of them. So it's taken a long time for us to get to this point. So originally X-ray machines were just exposing film, and then we went a little bit further than that and we got a computerized image to get that picture rather than using X-ray film, which is probably expensive. Instead it just had a detector which was able, and now with even better processing power we can get slice after slice after slice of an area of a person, or even I suppose the whole body, but it is rarely necessary to do a whole body. Usually they know where they're looking, and build up those slices in 3 dimensions. So it wasn't possible till now because computers needed the processing power to put that 3-dimensional image together and get all the voxels together and make an entire image. And so that comes up a little in the exam questions. Okay, so I'm going to get an exam question now and show how that voxel thing plays out to get the final answer. And it's ridiculously simple once you know what you have to do. You don't have to go through that whole thing that we just did, which is simple, but is lots of steps one after another, and I can see how a student might get lost. But in terms of knowing what you have to do to figure out the voxels, it is, I promise you, quite simple. You just take away the background radiation and then divide by 3 and you'll get your answer. So let me find an exam question for you.